Hi, welcome to this course on computing basics for security. My name is Kim, and I work as a technical program manager in security. I grew up with computers and the internet, but didn't really consider security as a career opportunity until I saw how it was interwoven into technology. Before my first security job, I worked on a cloud application team and had to regularly interact with the security team. It was my first experience working with security, but the idea of protecting information and working with others towards that goal was exciting to me. As a result, I decided to work towards my CISSP, which led me to some new job opportunities at my company, and I was then able to move into security. At this point, if you've been following along, you've already explored a variety of concepts useful to the security field, including security domains and networking. I'm excited to join you during the next part of the program. We'll take it slow so that you can understand these topics in practical ways. The focus of this course is computing basics. When you understand how the machines in an organization's system work, it helps you do your job as a security analyst more efficiently. Part of your job as a security analyst is to keep systems protected from possible attacks. You're one of the first levels of defense in protecting an organization's data. To do this effectively, it's helpful to understand how the system you're protecting works. In addition, you may need to investigate events to help correct errors in the system. Being familiar with Linux operating system and its associated commands, and also being able to interact with an organization's data through SQL will help you with that. In this course, you'll learn about operating systems and how they relate to applications and hardware. Next, you'll explore the Linux operating system in more detail. Then you'll use the Linux command line within a security context. Finally, we'll discuss how you can use SQL to query databases while working as a security analyst. I'm excited to explore all of these topics with you. Let's get started. How many times a week do you use a computer? For some of us, the answer might be a lot. They're incredible machines that let us do everything from using specialized applications when completing a task at work, to sending emails to loved ones in a distant place. Have you ever thought about how computers can do all of this? Well, that's where operating systems come in. In this section, we'll learn about common operating systems and we'll explore the main functions of an operating system. Then, we'll learn the relationship between operating systems, applications, and hardware. Finally, we'll compare graphical user interfaces and command line interfaces. The command line interface will be an essential part of your job as a security analyst. Understanding operating systems is an important foundation for your career in security. There's so much to explore. Let's begin. Hi, I'm Kim. I'm a technical program manager at Google. I'm currently working in the security, mergers, and acquisitions team, where I work with other companies that we purchase, and I help them integrate into the Google environment. I've held multiple roles before getting into cybersecurity and even technology. I first started working as a restaurant worker, and then I became an English tutor for international students at my local college. After doing multiple internships and graduating from university, I had my first opportunity to work in technology, and that's where my interest in technology and eventually cybersecurity began. I want to tell everyone with any type of background that you can get into cybersecurity. If you're interested in protecting information, if you're interested in protecting people in the future, security is there for you. There are so many different roles you can do, and all of the skills that you have now and that you've gathered previously can be applicable within security. The skill that I use the most is connecting with people every day. I can't get anything done unless I connect with them the right way. So that's actually the biggest skill I lean on the most working in security. A piece of advice I would give for someone new starting in the cybersecurity field is to keep an open mind. I started out with a degree in business, so I didn't even feel like I was technical enough to be where I am today. And before that, all of my experiences were either restaurant work or marketing work or just something that felt like it was unrelated to technology. But all of that helped me and motivated me to actually kind of get my feet more wet into technology and then eventually security. And before I knew it, that self-doubt was really replaced with more of a support from my peers and respect from other people that I've worked with. Devices like computers, smartphones, and tablets all have operating systems. If you've used a desktop or laptop computer, you may have used the Windows or Mac OS operating systems. Smartphones and tablets run on mobile operating systems like Android and iOS. Another popular operating system is Linux. Linux is used in the security industry, and as a security professional, it's likely that you'll interact with the Linux OS. So what exactly is an operating system? It's the interface between the computer hardware and the user. The operating system, or the OS, as it's commonly called, is responsible for making the computer run as efficiently as possible while also making it easy to use. Hardware may be another new term. Hardware refers to the physical components of a computer. The OS interface that we now rely on every day is something that early computers didn't have. In the 1950s, the biggest challenge with early computers was the amount of time it took to run a computer program. At the time, computers could not run multiple programs simultaneously. Instead, people had to wait for a program to finish running, reset the computer, and load up the new program. Imagine having to turn your computer on and off each time you had to open a new application. It would take a long time to complete a simple task, like sending an email. Since then, operating systems have evolved, and we no longer have to worry about wasting time in this way. Thanks to operating systems and their evolution, today's computers run efficiently. They run multiple applications at once, and they also access external devices like printers, keyboards, and mice. Another reason why operating systems are important is that they help humans and computers communicate with each other. Computers communicate in a language called binary, which consists of zeros and ones. The OS provides an interface to bridge this communication gap between the user and the computer, allowing you to interact with the computer in complex ways. Operating systems are critical for the use of computers. Likewise, OS security is also critical for the security of a computer. This involves securing files, data access, and user authentication to help protect and prevent against threats such as viruses, worms, and malware. Knowing how operating systems work is essential for completing different security-related tasks. For example, as a security analyst, you may be responsible for configuring and maintaining the security of a system by managing access. You may also be responsible for managing and configuring firewalls, setting security policies, enabling virus protection, and performing auditing, accounting, and logging to detect unusual behavior. All these tasks require a deep understanding of operating systems, and as we continue this course, we'll explore operating systems in greater detail. Previously, you learned about what operating systems are. Now, let's discuss how they work. In this video, you'll learn what happens with an operating system, or OS, when someone uses a computer for a task. Think about when someone drives a car. They push the gas pedal and the car moves forward. They don't need to pay attention to all the mechanics that allow the car to move. Just like a car can't work without its engine, a computer can't work without its operating system. The job of an OS is to help other computer programs run efficiently. The OS does this by taking care of all the messy details related to controlling the computer's hardware, so you don't have to. First, let's see what happens when you turn on the computer. When you press the power button, you're interacting with the hardware. This boosts the computer and brings up the operating system. Booting the computer means that a special microchip called the BIOS is activated. On many computers built after 2007, the chip was replaced by the UEFI. Both BIOS and UEFI contain booting instructions that are responsible for loading a special program called the bootloader. Then, the bootloader is responsible for starting the operating system. And just like that, your computer is on. As a security analyst, understanding these processes can be helpful for you. Vulnerabilities can occur in something like a booting process. Often, the BIOS is not scanned by the antivirus software, so it can be vulnerable to malware infection. Now that you learned how to boot the operating system, let's look at how you and all users communicate with the system to complete a task. The process starts with you, the user. And to complete tasks, you use applications on your computer. An application is a program that performs a specific task. When you do this, the application sends your request to the operating system. From there, the operating system interprets this request and directs it to the appropriate component of the computer's hardware. In the previous video, we learned that the hardware consists of all the physical components of the computer. The hardware will also send information back to the operating system, and this in turn is sent back to the application. Let's give a simple overview of how this works when you want to use the calculator on your computer. You use your mouse to click on the calculator application on your computer. When you type in the number you want to calculate, the application communicates with the operating system. Your operating system then sends the calculation to a component of the hardware, the central processing unit, or CPU. Once the hardware does the work of determining the final number, it sends the answer back to your operating system. Then it can be displayed in your calculator application. Understanding this process is helpful when investigating security events. Security analysts should be able to trace back through this process flow to analyze where a security event could have occurred. Just like a mechanic needs to understand the inner workings of a car more than an average driver. Recognizing how operating systems work is important knowledge for a security analyst. Now we're ready to discuss a different aspect of your operating system. Not only does the OS interact with other parts of your computer, but it's also responsible for managing the resources of the system. This is a big task that requires a lot of balance to make sure all the resources of the computer are used efficiently. Think of this like the concept of energy. A person needs energy to complete different tasks. Some tasks need more energy, while others require less. For example, going for a run requires more energy than watching TV. A computer's OS also needs to make sure that it has enough energy to function correctly for certain tasks. Running an antivirus scan on your computer will use more energy than using the calculator application. Imagine your computer is an orchestra. Many different instruments like violins, drums, and trumpets are all part of the orchestra. An orchestra also has a conductor to direct the flow of the music. In a computer, the OS is the conductor. The OS handles resource and memory management to ensure the limited capacity of the computer system is used where it's needed most. A variety of programs, tasks, and processes are constantly competing for the resources of the central processing unit, or CPU. They all have their own reasons why they need memory, storage, and input-output bandwidth. The OS is responsible for ensuring that each program is allocating and deallocating resources. All this occurs in your computer at the same time so that your system functions efficiently. Much of this is hidden from you as a user. For example, your browser's task manager will list all of the tasks that are being processed, along with their memory and CPU usage. As an analyst, it's helpful to know where a system's resources are used. Understanding usage of resources can help you respond to an incident and troubleshoot applications in the system. For example, if a computer is running slowly, an analyst might discover it's allocating resources to malware. A basic understanding of how operating systems work will help you better understand the security skills you will learn later in this program. Now that you've learned the inner workings of computers, let's discuss how users and operating systems communicate with each other. So far, you've learned that a computer has an operating system, hardware, and applications. Remember, the operating system communicates with the hardware to execute tasks. In this video, you'll learn how the user, that's you, interacts with the operating system in order to send tasks to the hardware. The user communicates with the operating system via an interface. A user interface is a program that allows the user to control the functions of the operating system. Two user interfaces that we'll discuss are the graphical user interface, or GUI, and the command line interface, or CLI. Let's cover these interfaces in more detail. A GUI is a user interface that uses icons on the screen to manage different tasks on the computer. Most operating systems can be used with a graphical user interface. If you've used a personal computer or a cell phone, you have experience operating a GUI. Most GUIs include these components: a start menu with program groups, a taskbar for launching programs, and a desktop with icons and shortcuts. All these components help you communicate with the OS to execute tasks. In addition to clicking on icons, when you use a GUI, you can also search for files or applications from the start menu. You just have to remember the icon or name of the program to activate an application. Now let's discuss the command line interface. In comparison, The command line interface, or CLI, is a text-based user interface that uses commands to interact with the computer. These commands communicate with the operating system and execute tasks like opening programs. The command line interface is a much different structure than the graphical user interface. When you use a CLI, you'll immediately notice a difference. There are no icons or graphics on the screen. The command line interface looks similar to lines of code used in certain text languages. A CLI is more flexible and more powerful than a GUI. Think about using a CLI like creating whatever meal you'd like from ingredients bought at a grocery store. This gives you a lot of control and customization about what you're going to eat. In comparison, using the GUI is more like ordering food from a restaurant. You can only order what's on the menu. If you want both a noodle dish and pizza, but the first restaurant you go to only has pizza, you'll have to go to another restaurant to order the noodles. With a graphical user interface, you must do one task at a time. But the command line interface allows for customization, which lets you complete multiple tasks simultaneously. For example, imagine you have a folder with hundreds of files of different file types, and you need to move only the JPEG files to a new folder. Think about how slow and tedious this would be as you use a GUI to find each JPEG file in this folder and move it into the new one. On the other hand, the CLI would allow you to streamline this process and move them all at once. As you can see, there are very big differences in these two types of user interfaces. As a security analyst, some of your work may involve command line interface. When analyzing logs or authenticating and authorizing users, security analysts commonly use a CLI in their everyday work. In this video, we discuss two types of user interfaces. You learn that you already have experience using a graphical user interface, as most personal computers and cell phones use a GUI. And you were introduced to the command line interface. Later in the program, you'll learn how to use a CLI in Linux and how relevant it is to your daily work as a security analyst. You'll get practical experience communicating through the command line. Pretty exciting, right?
My name is Ellen, and I am a security engineering manager at Google, focused in on how Google uses the cloud. Cybersecurity wasn't a field when I got started in technology. It's something I came to later. I got started in technology when I was working retail at a poster store, and we needed to build a website, and my feet hurt, and I really needed to sit down. And so I asked friends to teach me how to do HTML so I could sit down while working and I could let my blisters have a rest. While I was at the poster store, one of our customers worked at a startup and used to get employee photos framed, and I asked them for feedback on my website, and they ended up giving me an internship. One of the specialties that I ended up having was API design, or designing the interface by which a developer communicates with the machine. As part of that, I got into a job where I was designing a miniature version of an operating system for security technology and started learning security from there. Most of the people I know from cybersecurity, especially in the early days, do not have a degree at all, or if they do, they have a degree like I do in something like philosophy or poetry. Almost everyone learned on their own by experimenting, by talking to people, by reading. And so I would say no technical background is required. And in fact, having a background where you're used to being out in the real world can sometimes make cybersecurity make more sense and help you make more balanced choices. In almost all areas, there is a security community that you can find. Figure out where they are, look for local conferences, start talking to people. It's a lot more fun to learn that way than it is in a vacuum. I've found that most people, if you come to them and say, hey, you're really good at this thing, would you mind if I bought you a coffee and you showed me how to do it? That they'll always pretty much say yes. The advice I give to people who don't have technical backgrounds, the first one is I wouldn't be afraid of the technology. It can seem like only somebody with a computer science degree could ever understand things, but these concepts, these technologies are understandable by anyone. And so never let the fact that you might not have a technical background get in the way. Just pick an area that interests you and start diving in. And as long as you're curious and as long as you find it interesting, you'll learn the technology.
We did it. What a great section of learning. The best thing is that we did this together and covered some very useful topics. Let's recap this section's lessons. As a security analyst, it's important that you understand the systems that you're working with. Understanding computer basics will help you do your job more effectively and efficiently. In this section, we covered common operating systems. We also discussed the main functions of an operating system. Importantly, you learned about the relationship between operating systems, applications, and hardware. It was nice to learn how they flow together like an orchestra. In addition, you learned about the differences between the graphical user interface and the command line interface. Understanding the command line interface will be very important for your work. I enjoyed exploring the world of operating systems with you. Knowing how operating systems work is an important step in preparing for a position as a security analyst. You're doing great. Let's keep moving forward with this program. In the next section, we'll focus specifically on the Linux operating system. Welcome back. We have another important topic to explore. Previously, you learned about operating systems and user interfaces. You learned how operating systems work and how resources are allocated in computers. We also reviewed several common operating systems. You may already have a favorite operating system. It's common to hear that people are fans of one over another. But in the security world, Linux is commonly used. In this section, you'll be learning more about the Linux operating system and how it's used in everyday tasks in security. First, you'll learn about the architecture of Linux. After this, we'll compare the different distributions of Linux that are available. Lastly, you'll explore the shell, a key Linux component that allows you to communicate with the system. I remember when I first learned about the Linux OS, and I'm really happy to explore it with you now. You might have seen or heard the name Linux in the past, but did you know Linux is the most used operating system in security today? Let's start by taking a look at Linux and how it's used in security. Linux is an open source operating system. It was created in two parts. In the early 1990s, two different people were working separately on projects to improve computer engineering. The first person was Linus Torvalds. At the time, the Unix operating system was already in use. He wanted to improve it and make it open source and accessible to anyone. What was revolutionary was his introduction of the Linux kernel. We're going to learn what the kernel does later. Around the same time, Richard Stallman started working on GNU. GNU was also an operating system based on Unix. Stallman shared Torvalds' goal of creating software that was free and open to anyone. After working on GNU for a few years, the missing element for this software was the kernel. Together, Torvalds and Stallman's innovations made what is commonly referred to as Linux. Now that you've learned the history behind Linux, let's take a look at what makes Linux unique. As mentioned before, Linux is open source, meaning anyone can have access to the operating system and the source code. Linux and many of the programs that come with Linux are licensed under the terms of the GNU public license, which allow you to use, share, and modify them freely. Thanks to Linux's open source philosophy, as well as its strong feature set, an entire community of developers has adopted this operating system. These developers are able to collaborate on projects and advance computing together. As a security analyst, you'll discover that Linux is used at different organizations. More specifically, Linux is used in many security programs. Another unique feature about Linux is the different distributions or varieties that have been developed. Because of the large community contribution, there are over 600 distributions of Linux. Later, you'll learn more about distributions. Finally, let's take a look at how you would use Linux in an entry-level security position. As a security analyst, you'll use many tools and programs in everyday work. You might examine different types of logs to identify what's going on in a system. For example, you might find yourself looking at an error log when investigating an issue. Another place where you will use Linux is to verify access and authorization in an identity and access management system. In security, managing access is key in order to ensure a secure system. We'll take a closer look into access and authorization later. Finally, as an analyst, you might find yourself working with specific distributions designed for a particular task. For example, you might use a distribution that has a digital forensic tool to investigate what happened in an event alert. You might also use a distribution that's for pen testing and offensive security to look for vulnerabilities in the system. Distributions are created to fit the needs of their users. I hope you're excited to learn more about Linux. This will be a very useful skill in the security field.
Hi, I'm Phil. I'm the Chief Information Security Officer for Google Cloud, and a big part of that is, of course, cybersecurity. So in cyber, you've always got to learn, you've always got to stay up to date for the simple reason that technology and business and the world of our kind of digital lives is just always changing. The online services that you use today are probably very different even just from what they were 12 months ago. In the mid-90s, I worked on one of the world's first internet banking systems, and essentially we were building and coding all of the security ourselves. I remember working on, the first web browsers, the first web servers, the first implementations of encryption on the internet. This was even before Google even existed, and so this was at the very beginning of the internet, and we were literally kind of assembling and building this and learning how to do it as we went along. When you're first getting into cybersecurity, it's important to not get overwhelmed. It's a very big space, and all of us started off at where you are today, and we had to learn into that. At one point, I didn't know Linux, I didn't know how to program, I didn't know various parts of other operating systems, and I had to learn step by step how all of that worked and gradually built up that knowledge over time. And even now, I still have to look things up occasionally because I don't keep everything in my head all at once, and that's totally fine. When you're approaching a new situation, you're always going to have a degree of anxiety about whether you're going to be able to learn it quickly enough. And generally, with enough experience, you gradually get comfortable that you will. But again, this is important to remember that you don't have to learn everything about everything all at once. Most of the time, you learn enough to be enough of value in the initial part of the process, then you learn as you go. Start off by writing a few lines of simple code or looking at somebody else's code and trying to understand what it does, and then change it a little bit and just incrementally work into this. Build that foundation of knowledge that gives you the ability to learn other things, and I think things will stem from that.
Let me start with a quick question that may seem unrelated to security. Do you have a favorite building? And what is it about its architecture that impresses you the most? The windows? The structure of the walls? Just like buildings, operating systems also have an architecture and are made up of discrete components that work together to form the whole. In this video, we're going to look at all the components that together make up Linux. The components of Linux include the user, applications, the shell, the file system hierarchy standard, the kernel, and the hardware. Don't worry, we'll go into these components one by one together. First, you're the user. The user is the person interacting with the computer. In Linux, you're the first element to the architecture of the operating system. You're initiating the tasks or commands that the OS is going to execute. Linux is a multi-user system. This means that more than one user can use the system's resources at the same time. The second element of the architecture is the applications within a system. An application is a program that performs a specific task, such as a word processor or a calculator. You might hear the word application and programs used interchangeably. As an example, one popular Linux application that we'll learn more about later is Nano. Nano is a text editor. This simple application helps you keep notes on the screen. Linux applications are commonly distributed through package managers. We'll learn more about this process later. The next component in the architecture of Linux is the shell. This is an important element because it is how you will communicate with the system. The shell is a command line interpreter. It processes commands and outputs the results. This might sound familiar. Previously, we learned about the two types of user interfaces, the GUI and the CLI. You can think of the shell as a CLI. Another element of the architecture of Linux is the File System Hierarchy Standard, or FHS. It's the component of the Linux OS that organizes data. An easy way for you to think about the FHS is to think about it as a filing cabinet of data. The FHS is how data is stored in a system. It's a way to organize data so that it can be found when the data is accessed by the system. That brings us to the kernel. The kernel is a component of the Linux OS that manages processes and memory. The kernel communicates with the hardware to execute the commands sent by the shell. The kernel uses drivers to enable applications to execute tasks. The Linux kernel helps ensure that the system allocates resources more efficiently and makes the system work faster. Finally, the last component of the architecture is the hardware. Hardware refers to the physical components of a computer. You can compare this to software applications, which can be downloaded into a system. The hardware in your computer are things like the CPU, mouse, and keyboard. Congratulations! We've now covered the architecture of Linux. An understanding of these components will help you become increasingly familiar with Linux. Let's learn a little bit more about Linux and what you need to know about this operating system when working as a security analyst. Linux is a very customizable operating system. Unlike other operating systems, there are different versions available for you to use. These different versions of Linux are called distributions. You might also hear them called distros or flavors of Linux. It's essential for you to understand the distribution that you're using, so you know what tools and apps are available to you. For example, Debian is a distro that has different tools than the Ubuntu distribution. Let's use an analogy to describe Linux distributions. Think of the OS as a vehicle. First, we'll start with its engine. That would be the kernel. Just as the engine makes the vehicle run, the kernel is the most important component of the Linux OS. Because the Linux kernel is open source, anyone can take the kernel and modify it to build a new distribution. This is comparable to a vehicle manufacturer taking an engine and creating different types of vehicles: trucks, cars, vans, convertibles, buses, airplanes, and so on. These different types of vehicles can be compared to different Linux distributions. A bus is used to transport lots of people. A truck is used to transport a large number of goods across vast distances. An aircraft transports passengers or goods by air. Just as each vehicle serves its own purpose, different distributions are used for different reasons. Additionally, vehicles all have different components which distinguish them from each other. Aircrafts have control panels with buttons and knobs. Regular cars have 4 tires, but trucks can have more. Similarly, different Linux distributions contain different pre-installed programs, user interfaces, and much more. A lot of this is based on what the Linux user needs. But some distros are also chosen based on preference, the same way a sports car might be chosen as a vehicle. The advantage of using Linux as an OS is that you can customize it. Distributions include the Linux kernel, utilities, a package management system, and an installer. We learned earlier that Linux is open source, and anyone can contribute to adding to the source code. That is how new distributions are created. All distros are derived from another distro, but there are a few that are considered parent distributions. Red Hat is a parent of CentOS, and Slackware is the parent of SUSE. Both Ubuntu and Kali Linux are derived from Debian. As we continue, we're going to take a look at some of the distributions most commonly used by security analysts. The more you understand these distributions, the easier your work will be. In this section, we're going to cover a Linux distribution that's widely used in security and discuss Kali Linux. Kali Linux is a trademark of offensive security and is Debian derived. This open source distro was made specifically with penetration testing and digital forensics in mind. There are many tools pre-installed into Kali Linux. It's important to note that Kali Linux should be used on a virtual machine. This prevents damage to your system in the event its tools are used improperly. An additional benefit is that using a virtual machine gives you the ability to revert to a previous state. As security professionals advance in their careers, some specialize in penetration testing. A penetration test is a simulated attack that helps identify vulnerabilities in systems, networks, websites, applications, and processes. Kali Linux has numerous tools that are useful during penetration testing. Let's look at a few examples. To begin, Metasploit can be used to look for and exploit vulnerabilities on machines. Burp Suite is another tool that helps to test for weaknesses in web applications. And finally, John the Ripper is a tool used to guess passwords. As a security analyst, your work might involve digital forensics. Digital forensics is a practice of collecting and analyzing data to determine what has happened after an attack. For example, you might take an investigative look at data related to a network activity. Kali Linux is also a useful distribution for security professionals who are involved in digital forensic work. It has a large number of tools that can be used for this. As one example, tcpdump is a command line packet analyzer. It's used to capture network traffic. Another tool commonly used in the security profession is Wireshark. It has a graphical user interface that can be used to analyze live and captured network traffic. And as a final example, Autopsy is a forensic tool used to analyze hard drives and smartphones. These are just a few tools included with Kali Linux. This distribution has many tools used to conduct pen testing and digital forensics. We've explored how Kali Linux is an important distribution that's widely used in security, but there are other distributions that security professionals use as well. Next, we'll explore a few more distributions. Welcome back. In this video, we're going to discuss the Linux shell. This part of the Linux architecture is where the action will happen for you as a security analyst. We introduced the shell with other components of the Linux OS earlier, but let's take a deeper look at what the shell is and what it does. The shell is the command line interpreter. That means it helps you communicate with the operating system through the command line. Previously, we discussed a command line interface. This is essentially the shell. The shell provides the command line interface for you to interact with the OS. To tell the OS what to do, you enter the commands into this interface. A command is an instruction telling the computer to do something. The shell communicates with the kernel to execute these commands. Earlier, we discussed how the operating system helps humans and computers speak with each other. The shell is part of the OS that allows you to do this. Think of this as a very helpful language interpreter between you and your system. Since you do not speak computer language or binary, you can't directly communicate with your system. This is where the shell comes in to help you. Your OS doesn't need the shell for most of its work, but it is an interface between you and what your system can offer. It allows you to perform math, run tests, and execute applications. More importantly, it allows you to combine these operations and connect applications to each other to perform complex and automated tasks. Just as there are many Linux distributions, there are many different types of shells. We'll primarily focus on the bash shell in this course. Let's continue to learn more about the shell. Hello again. In this video, we're going to learn a little more about the shell and how to communicate with it. Communicating with a computer is like having a conversation with your friend. One person asks a question and the other person answers with a response. If you don't know the answer, you can just say you don't know the answer. When you communicate with the shell, the commands in the shell can take input, give output, or give error messages. Let's explore standard input, standard output, and the error messages in more detail. Standard input consists of information received by the OS via the command line. This is like you asking your friend a question during a conversation. The information is input from your keyboard to the shell. If the shell can interpret your request, it asks the kernel for the resources it needs to execute the related task. Let's take a look at this through echo, a Linux command that outputs a specified string of text. String data is data consisting of an order sequence of characters. In our example, we'll just have it output the string of hello. So as input, we'll type echo hello into the shell. Later, when we press enter, we'll get the output. But before we do that, let's first discuss the concept of output in more detail. Standard output is the information returned by the OS through the shell. In the same way that your friend gives an answer to your question, output is a computer's response to the command you input. Output is what you receive. Let's pick up where we left off in our example and send the input of echo hello to the OS by pressing enter. Immediately, the shell returns the output of hello. Finally, standard error contains error messages returned by the OS through the shell. Just like your friend might indicate that they can't answer a question, the system responds with an error message if they can't respond to your command. Sometimes this might occur when we misspell a command or the system doesn't know the response to the command. Other times, it might happen because we don't have the appropriate permissions to perform a command. we'll explore another example that demonstrates standard error. Let's input echo hello into the shell. Notice I intentionally misspelled echo as ECO. When we press enter, an error message appears. To wrap up, we've covered the basics of communication with the shell. Communication with the shell can only go in one of three ways. The system receives a command. This is input. The system responds to the command and produces output. And finally, the system doesn't know how to respond, resulting in an error. Later, you'll become much more familiar with this as we explore commands useful for security professionals. We've made it to the end of this section. Great work! Let's recap what you've just completed. In this section, you learned about the Linux operating system. We examined the architecture of Linux. In our exploration of the different distributions of Linux, we discussed some of the most widely used distros in security. You were introduced to Kali Linux, Ubuntu, Parrot, Red Hat, and CentOS distributions. Finally, you learned about the shell and its role as an interpreter between the user and operating system. Congratulations! You're doing great, and we have more useful topics to come. In the next part of the program, you'll learn specific commands to use within the shell while working as a security analyst. Let's continue on. Learning to communicate in a new way can be exciting. Maybe you've learned a new language and can remember this feeling. Perhaps a lot of us share this excitement with young children as they are expanding their vocabulary. Others, including me, remember a sense of wonder when we first used a specialized language to communicate with a computer. In this section, we'll continue to learn more about Linux and how to communicate with the OS through its shell. You'll utilize the command line to communicate with the OS. You'll learn how to input commands in the shell and learn about some of the core Linux commands that you'll use as a security analyst. Specifically, this includes navigating and managing the file system. You'll also focus on authenticating and authorizing users. This means you'll be able to use a command line to add and delete users from the system and to control what they have access to. Finally, there's always more to learn. So we'll cover accessing resources that support learning new Linux commands. I remember when I first learned about the command line and was shocked at the capabilities it provided. I didn't need to click through multiple screens to get tasks done. Although it took some practice and time to get used to, it has been one of the biggest tools at my disposal. After this section, you'll have a practical experience in an area important to the work of a security analyst, using Linux commands. Welcome back. Before we get into specific Linux commands, let's explore in more detail the basics of communicating with the OS through the shell. Being able to utilize Linux commands is a foundational skill for all security professionals. As a security analyst, you'll work with server logs and you'll need to know how to navigate, manage, and analyze files remotely without a graphical user interface. In addition, you'll need to know how to verify and configure users during group access. You'll also need to give authorization and set file permissions. That means that developing skills with the command line is essential for your work as a security analyst. When we learned about the Linux architecture, we learned that the shell is one of the main components of the operating system. We also learned that there are different shells. In this section, we'll utilize the Bash shell. Bash is the default shell in most Linux distributions. For the most part, the key Linux commands that you'll be learning in this section are the same across shells. Now that you know what shell you'll be using, let's go into how to write in Bash. As we discussed in the previous section, communicating with your OS is like a conversation. You type in commands and the OS responds with an answer to your command. A command is an instruction telling the computer to do something. We'll try out a command in Bash. Notice a $sign before the cursor. This is your prompt to enter a new command. Some commands might tell the computer to find something like a specific file. Others might tell it to launch a program. Or it might be to output a specific string of text. In the last section, when we discussed input and output, we explored how the echo command did this. Let's input the echo command again. You may notice that the command we just input is not complete. If we're going to use the echo command to output a specific string of text, we need to specify what the string of text is. This is what arguments are for. An argument is specific information needed by a command. Some commands take multiple arguments. So now, let's complete the echo command with an argument. We're learning some pretty technical stuff, so how about we output the words, "You are doing great." We'll add this argument, and then we'll press enter to get the output. In this example, our argument was a string of text. Arguments can provide other types of information as well. One thing that is really important in Linux is that all commands and arguments are case sensitive. This includes file and directory names. Keep that in mind as you learn more about how to use Linux in your day-to-day tasks as a security analyst. Okay, now that we've covered the basics of entering Linux commands and arguments through the bash shell, we're ready to learn some specific commands. This is exciting, so let's get to our next video. Welcome back. I hope you're learning a lot about how to communicate with the Linux OS. As we continue our journey into utilizing the Linux command line, we'll focus on how to navigate the Linux file system. Now, I want you to imagine a tree. What did you notice first about the tree? Would you say the trunk or the branches? These might definitely get your attention, but what about its roots? Everything about a tree starts in the roots. Something similar happens when we think about the Linux file system. Previously, we learned about the components of the Linux architecture. The File System Hierarchy Standard, or FHS, is the component of the Linux OS that organizes data. This file system is a very important part of Linux because everything we do in Linux is considered a file somewhere in the system's directory. The FHS is a hierarchical system, and just like with the tree, everything grows and branches out from the root. The root directory is the highest level directory in Linux. It's designated by a single slash. Subdirectories branch out from the root directory. The subdirectories branch out further and further away from the root directory. When describing the directory structure in Linux, slashes are used when tracing back through these branches to the root. For example, here, the first slash indicates the root directory. Then it branches out a level into the home subdirectory. Another slash indicates it is branching out again. This time, it's to the analyst subdirectory that is located within home. When working in security, it is essential that you learn to navigate a file system to locate and analyze logs, such as log files. You'll analyze these log files for application usage and authentication. With that background, we're now ready to learn the commands commonly used for navigating the file system. First, pwd prints the working directory onto the screen. When you use this command, the output tells you which directory you're currently in. Next, ls displays the names of files and directories in the current working directory. And finally, cd navigates between directories. This is the command you'll use when you want to change directories. Let's use these commands in bash. First, we'll type the command pwd to display the current location and then press enter. The output is the path to the analyst directory, where we're currently working. Next, let's input ls to display the files and directories within the analyst directory. The output is the name of 4 directories: logs, old reports, projects, and reports, and one file named updates.txt. So let's say we now want to go into the logs directory to check for unauthorized access. We'll input cd logs to change directories. We won't get any output on the screen from the cd command, but if we enter pwd again, its output indicates the working directory is logs. Logs is a subdirectory of the analyst directory. As a security analyst, you'll also need to know how to read file content in Linux. For example, you may need to read files that contain configuration settings to identify potential vulnerabilities. Or you might look at user access reports while investigating unauthorized access. When reading file content, there are some commands that will help you. First, cat displays the content of a file. This is useful, but sometimes you won't want the full contents of a large file. In these cases, you can use the head command. It displays just the beginning of a file, by default 10 lines. Let's try out these commands. Imagine that we want to read the contents of access.txt and we're already in the working directory where it's located. First, we input the cat command and then follow it with the name of the file, access.txt. And bash returns the full contents of this file. Let's compare that to the head command. When we input the head command followed by our file name, only the first 10 lines of this file are displayed. Wow, this section had lots of action, and it's just the beginning. I'm glad you learned how security analysts can use essential commands to navigate the system. Next, we'll explore how to manage this system. Now that we covered pwd, ls, and cd, and are familiar with these basic commands for navigating the Linux file system, let's look at a couple of ways to find what you need within this system. As a security analyst, your work will likely involve filtering for the information you need. Filtering means searching your system for specific information that can help you solve complex problems. For example, imagine that your team determines a piece of malware contains a string of characters. You might be tasked with finding other files with the same string to determine if those files contain the same malware. Later, we'll learn more about how you can use SQL to filter a database, but Linux is a good place to start basic filtering. First, we'll start with grep. The grep command searches a specified file and returns all lines in the file containing a specified string. Here's an example of this. Let's say we have a file called updates.txt, and we're currently looking for lines that contain the word OS. If the file is large, it would take a long time to visually scan for this. Instead, after navigating to the directory that contains updates.txt, we'll type the command grep os updates.txt into the shell. Notice how the grep command is followed by two arguments. The first argument is the string we're searching for, in this case, OS. The second argument is the name of the file we're searching through, updates.txt. When we press enter, bash returns all lines containing the word OS. Now, let's talk about piping. Piping is a Linux command that can be used for a variety of purposes. In a moment, we'll focus on how it can be used for filtering. But first, let's talk about the general idea of piping. The piping command sends a standard output of one command as standard input into another command for further processing. It's represented by the vertical bar character. In our context, we can refer to this as the pipe character. Take a moment and imagine a physical pipe. Physical pipes have two ends. On one end, for example, water might enter the pipe from a hot water tank. Then, it travels through the pipe and comes out on the other end in a sink. Similarly, in Linux, piping also involves redirection. Output from one command is sent through the pipe and then is used on the other side of the pipe. Earlier in this video, I explained how grep can be used to filter for strings of characters within a file. Grep can also be incorporated after a pipe. Let's focus on this example. The first command, ls, instructs the operating system to output the file and directory contents of the report's subdirectory. But because the command is followed by the pipe, the output isn't returned to the screen. Instead, it's sent to the next command. As we just learned, grep searches for a specified string of characters. In this case, it's users. But where is it searching? Since grep follows a pipe, the output of the previous command indicates where to search. In this case, that output is a list of files and directories within the report's subdirectory. It will return all files and directories that contain the word users. Okay, let's explore this in bash. So we can better understand how the filter works, let's first output everything in the reports directory. If we were already in the directory, we would just need to input ls. But since we're not, we'll also specify the path to this directory. When we press enter, the output indicates there are 7 files in the reports directory. Because we want to return only the files that contain the word users, we'll combine this ls command with piping and the grep command. As the output demonstrates, Linux has been instructed to return only files that contain the word users. The two files that don't contain this string no longer appear. So now you have two different ways that you can filter in Linux while working as an analyst. Navigating through files and filtering are just part of what you need to know. Let's keep exploring the Linux command line. Let's make some branches. What do I mean by that? Well, in a previous video, we discussed root directories and how other subdirectories branch off of the root directory. Let's think again about the file directory system as a tree. The subdirectories are the branches of the tree. They are all connected from the same root, but can grow to make a complex tree. In this video, we'll create directories and files and learn how to modify them. When it comes to working with data in security, organization is key. If we know where information is located, it makes it easier to detect issues and keep information safe. In a previous video, we've already discussed navigating between directories, but let's take a moment to examine directories more closely. It's possible you're familiar with the concept of folders for organizing information. In Linux, we have directories. Directories help organize files and subdirectories. For example, within a directory for reports, an analyst may need to create two subdirectories, one for drafts and one for final reports. Now that we know why we need directories, let's take a look at some essential Linux commands for managing directories and files. First, let's take note of commands for creating and removing directories. The mkdir command creates a new directory. In contrast, rmdir removes or deletes a directory. A helpful feature of this command is its built-in warning that lets you know a directory is not empty. This saves you from accidentally deleting files. Next, you'll use other commands for creating and removing files. The touch command creates a new file, and then the rm command removes or deletes a file. And last, we have our commands for copying and moving files or directories. The mv command moves a file or directory to a new location, and cp copies a file or directory into a new location. Okay, now we're ready to try out these commands. First, let's use the pwd command. And then let's display the names of the files and directories in the analyst directory with the ls command. Imagine that we no longer need the old reports directory that appears among the file contents. Let's take a look at how to remove it. We input the rmdir command and follow it with the name of the directory we want to remove, old reports. We can use the ls command to confirm that old reports has been deleted and no longer appears among the contents. Now, let's make another change. We want a new directory for drafts of reports. So we need to use the command mkdir and specify a name for this directory, drafts. If we input ls again, we'll notice the new directory drafts included among the contents of the analyst directory. Let's change into this new directory by entering cd drafts. If we run ls, it doesn't return any output, indicating that this directory is currently empty. But next, we'll add some files to it. Let's say we want to draft new reports on recently installed email and OS patches. To create these files, we input touch email _ patches.txt, and then touch os _ patches.txt. Running ls indicates that these files are now in the drafts directory. What if we realize that we only need a new report on OS patches and we want to delete the email patches report? To do this, we input the rm command and specify the file to delete as email _ patches.txt. Running ls confirms that it's been deleted. Now, let's focus on our commands for moving and copying. We realize that we have a file called email policy in the reports folder that is currently in draft format. So we want to move it into the newly created drafts folder. To do this, we need to change into the directory that currently has that file. Running ls in that directory indicates that it contains several files, including email_policy.txt. Then to move that file, we'll enter the mv command followed by 2 arguments. The first argument after mv identifies the file to be moved. The second argument indicates where to move it. If we change directories into drafts and then display its contents, we'll notice that the email policy file has been moved to this directory. We'll change back into reports. Displaying the file contents confirms that email_policy is no longer there. Okay, one more thing. Vulnerabilities.txt is a file that we want to keep in the reports directory. But since it affects an upcoming project, we also want to copy it into the projects directory. Since we're already in the directory that has this file, we'll use the cp command to copy it into the projects directory. Notice that the first argument indicates which file to copy, and the second argument provides the path to the directory that it will be copied into. When we press enter, this copies the vulnerabilities file into the projects directory, while also leaving the original within reports. Isn't it cool what we can do with these commands? Now let's focus on one more concept related to modifying files. In addition to using commands, you can also use applications to help you edit files. As a security analyst, file editors are often necessary for your daily tasks like writing or editing reports. A popular file editor is Nano. It's good for beginners. You can access this tool through the Nano command. Let's get familiar with Nano together. We'll add a title to our new draft report, os_patches.txt. First, we change into the directory containing that file. Then, we input Nano followed by the name of the file we want to edit, os_patches.txt. This brings up the Nano file editor with that file open. For now, we'll just enter the title OS Patches by typing this into the editor. We need to save this before returning to the command line, and to do so, we press Ctrl-O, and then enter to save it with the current file name. Then to exit, we press Ctrl-X. Great work! We've covered a lot of topics here, from creating and removing directories and files, to copying or moving them, and just now, we've added editing files. You're well on your way to learning Linux commands. Hi there. It's great to have you back. Let's continue to learn more about how to work in Linux as a security analyst. In this video, we'll explore file and directory permissions. We'll learn how Linux represents permissions and how you can check for the permissions associated with files and directories. Permissions are the type of access granted for a file or directory. Permissions are related to authorization. Authorization is the concept of granting access to specific resources in a system. Authorization allows you to limit access to specified files or directories. A good rule to follow is that data access is on a need-to-know basis. You can imagine the security risk it would impose if anyone could access or modify anything they wanted to on a system. There are 3 types of permissions in Linux that an authorized user can have. The first type of permission is read. On a file, read permissions means contents on the file can be read. On a directory, this permission means you can read all files in that directory. Next are write permissions. Write permissions on a file allow modifications of contents of the file. On a directory, write permissions indicate that new files can be created in that directory. Finally, there are also execute permissions. Execute permissions on files mean that the file can be executed if it's an executable file. Execute permissions on directories allow users to enter into a directory and access its files. Permissions are granted for 3 different types of owners. The first type is the user. The user is the owner of the file. When you create a file, you become the owner of the file, but the ownership can be changed. Group is the next type. Every user is a part of a certain group. A group consists of several users, and this is one way to manage a multi-user environment. Finally, there is Other. Other can be considered all other users on the system. Basically, anyone else with access to the system belongs to this group. In Linux, file permissions are represented with a 10-character string. For a directory with full permissions for the user group, this string would be d rwx rwx rwx. Let's examine what this means more closely. The first character indicates the file type. As shown in this example, D is used to indicate it is a directory. If this character contained a hyphen instead, it would be a regular file. The second, third, and fourth characters indicate the permissions for the user. In this example, R indicates the user has read permissions. W indicates the user has write permissions, and X indicates the user has execute permissions. If one of these permissions was missing, there would be a hyphen instead of the letter. In the same way, the fifth, sixth, and seventh characters indicate permissions for the next owner type, group. As it shows here, the type group also has read, write, and execute permissions. There are no hyphens to indicate that any of these permissions haven't been granted. Finally, the 8th through 10th characters indicate permissions for the last owner type, Other. They also have read, write, and execute permissions in this example. Ensuring files and directories are set with their appropriate access permissions is critical to protecting sensitive files and maintaining the overall security of a system. For example, payroll departments handle sensitive information. If someone outside of the payroll group could read this file, this would be a privacy concern. Another example is when the user, the group, and other can all write to a file. This type of file is considered a world writable file. World writable files can pose significant security risks. So how do we check permissions? First, we need to understand what options are. Options modify the behavior of the command. The options for a command can be a single letter or a full word. Checking permissions involves adding options to the ls command. First, ls-l displays permissions to files and directories. You might also want to display hidden files and identify their permissions. Hidden files, which begin with a period before their name, don't normally appear when you use ls to display file contents. Entering ls-a displays hidden files. Then, you can combine these two options to do both. Entering ls-la displays permissions to files and directories, including hidden files. Let's get into Bash and try out these options. Right now, we're in the project subdirectory. First, let's use the ls command to display its contents. The output displays the files in this directory, but we don't know anything about their permissions. By using ls-l instead, we get expanded information on these files. Let's do this. The file names are now on the right side of each row. The first piece of information in each row shows the permissions in the format that we discussed earlier. Since these are all files and not directories, notice how the first character is a hyphen. Let's focus on one specific file, project1.txt. The second through fourth characters of its permissions show us the user has both read and write permissions, but lacks execute permissions. In both the 5th through 7th characters and 8th through 10th characters, the sequence is R-. This means group and other have only read privileges. After the permissions, ls-l first displays the username. Here, that's us, analyst. Next comes the group name, in our case, the security group. Now let's use ls-a. The output includes two more files, hidden files with the names .hidden1.txt and .hidden2.txt. Finally, we can also use ls-la to show the permissions for all files, including these hidden files. I thought that was pretty interesting. Did you? You now know a little more about file permissions and ownership. This will be helpful when working in security because monitoring and setting correct permissions is essential for protecting information. Take a small break and meet me in the next video. Hi there. In the previous video, you learned how to check permissions for a user. In this video, we're going to learn about changing permissions. When working as a security analyst, there may be many reasons to change permissions for a user. A user may have changed departments or been assigned to a different work group. A user might simply no longer be working on a project that requires certain permissions. These changes are necessary in order to protect system files from being accidentally or deliberately altered or deleted. Let's explore a related command that helps control this access. In this video, we'll learn about chmod. Chmod changes permissions on files and directories. The command chmod stands for change mode. There are two modes for changing permissions, but we'll focus on symbolic. The best way to learn about how chmod works is through an example. I know this has a lot of details, but we'll break this down. Also, please keep in mind that, like many Linux commands, you don't have to memorize the information and can always find a reference. With chmod, you need to identify which file or directory you want to adjust permissions for. This is the final argument, in this case a file named access.txt. The first argument, added directly after the chmod command, indicates how to change permissions. Right now, this might seem hard to interpret, but soon we'll understand why this is called symbolic mode. Previously, we learned about the three types of owners: user, group, and other. To identify these with chmod, we use U to represent the user, G to represent the group, and O to represent other. In this particular example, G indicates we will make some changes to group permissions, and O to permissions for other. These owner types are separated by a comma in this argument. But do we want to add or take away permissions? Well, for this, we use mathematical operators. So the plus sign after G means we want to add permissions for group, and the minus sign after O means we want to take them away from other. And the last question is, what kind of changes? We've already learned that R represents read permissions, W represents write permissions, and X represents execute permissions. So in this case, the W indicates that we are adding write permissions to the group, and R indicates that we are taking away read permissions from other. This is still very complex, but now that we've broken it down, perhaps it doesn't seem quite so much like a foreign language. And remember, you don't have to memorize this all. Let's give this new command a try. We'll start out in the logs subdirectory. If we use the ls-l command, it will output the permissions for the file. It shows the permissions for the only file in this directory, access.txt. Previously, we learned how to read these permissions. The second through fourth characters indicate that the user has read and write permissions. The fifth through seventh characters show the group only has read permissions. And the 8th through 10th characters show that other only has read permissions. We need to adjust these permissions. We want to ensure analysts in the security group have write permission, but take away read permissions from the owner type other. So we add write permissions for group and remove read permissions for other. Let's run ls-l again. This shows a change in the permissions for access.txt. Notice how in the middle segment of permissions for the group W has been added to give write permissions. And another change is that the R has been removed in the last segment, indicating that read permissions for other have been removed. As mentioned earlier, these hyphens indicate a lack of permissions. Now other is lacking all permissions. Though it requires practice, working in Linux becomes more natural with time. I'm glad you're learning a little more about how to use Linux. Welcome back. In this video, we are going to discuss adding and deleting users. This is related to the concept of authentication. Authentication is the process of a user proving that they are who they say they are in the system. Just like in a physical building, not all users should be allowed in. Not all users should get access to the system. But we also want to make sure everyone who should have access to the system has it. That's why we need to add users. New users can be new to the organization or new to a group. This could be related to a change in organizational structure or simply a directive from management to move someone. And also, when users leave the organization, they need to be deleted. They should no longer have access to any part of the system. Or if they simply changed groups, they should be deleted from groups that they are no longer a part of. Now that we've sorted out why it's important to add and delete users, let's discuss a different type of user, the root user. A root user, or super user, is a user with elevated privileges to modify the system. Regular users have limitations, where the root does not. Individuals who need to perform specific tasks can be temporarily added as root users. Root users can create, modify, or delete any file and run any program. Only root users or accounts with root privileges can add new users. So you may be wondering how you become a super user. Well, one way is logging in as the root user, but running commands as the root user is considered to be bad practice when using Linux. Why is running commands as the root user potentially problematic? The first problem with logging in as root is the security risks. Malicious actors will try to breach the root account. Since it's the most powerful account, to stay safe, the root account should have logins disabled. Another problem is that it's very easy to make irreversible mistakes. It's very easy to type the wrong command in the CLI, and if you're running as the root user, you run a higher risk of making an irreversible mistake, such as permanently deleting a directory. Finally, there's the concern of accountability. In a multi-user environment like Linux, there are many users. If a user is running as root, there is no way to track who exactly ran a command. One solution to help solve this problem is sudo. Sudo is a command that temporarily grants elevated permissions to specific users. This provides more of a controlled approach compared to root, which runs every command with root privileges. Sudo solves lots of problems associated with running as root. Sudo comes from super user do and lets you execute commands as an elevated user without having to sign in and out of another account. Running sudo will prompt you to enter the password for the user you're currently logged in as. Not all users on a system can become a super user. Users must be granted sudo access through a configuration file called the sudoers file. Now that we've learned about sudo, let's learn how we can use it with another command to add users. This command is user add. User add adds a user to the system. Only root or users with sudo privileges can use the user add command. Let's look at a specific example in which we need to add a user. We'll imagine a new representative is joining the sales department and will be given the username of salesrep7. We're tasked with adding them to the system. Let's try adding the new user. First, we need to use the sudo command followed by the user add command. And then last, the username we want to add, in this case, salesrep7. This command doesn't display anything on the screen, but since we get a new bash cursor and not an error message, we can feel confident that the command worked successfully. If it didn't, an error message would have appeared. Sometimes an error has to do with something simple, like misspelling user add. Or it might be because we didn't have sudo privileges. Now let's learn how to do the opposite. Let's learn how to delete a user with user del. User del deletes a user from the system. Similarly, we need root permissions that we'll access through sudo to use user del. Let's go back to our example of the user we added. Let's imagine 2 months later, the sales representative we just added to the system leaves the company. That user should no longer have access to the system. Let's delete that user from the system. Again, the sudo command is used first. Then we add the user del command. Last, we add the name of the user we want to delete. Again, we know it ran successfully because there is a new bash cursor and not an error message. Now, we've covered how to add and delete users and how these actions require sudo. When using sudo, we have to use our best judgment. These special privileges must be used responsibly to ensure a secure system.
My name's Damar. I'm a security engineer here at Google. I've always wanted to get into cybersecurity since I was a kid. A lot of the cartoons I watched, they had like floppy disk or flash drives, and they would put that in the computer and kind of like cause havoc. So I always thought that was really cool. I've had quite a bit of jobs before coming to Google. I've originally started out making smoothies at Jamba Juice. I got my first like IT technological kind of job at Geek Squad, and then eventually I came here and became a security engineer. My advice to people trying to get into cybersecurity is it may be a lot easier than you think. It definitely was a lot easier than I thought. Something that I learned jumping in myself is that you're not going to be able to learn everything all at once, and you're not going to need to know everything all at once. Linux is very important because it's broadly used across pretty much every company. You may use Linux to curate logs. It's a very common practice. You may also use Linux to set up bash jobs that will help with routine tasks within Linux. I first got interested in learning Linux from the Jurassic Park movie. There's a scene in the movie where they need to reactivate the electrical doors, and they have to use a Unix operating system to do so. Later on, I learned what Unix was and how Linux came from it, and it inspired me to learn more about Linux. The best advice I can give someone that's trying to learn Linux and Linux commands is don't get discouraged by any small hiccups that come up. Just keep with it, stick with it. Think of it as when you first learned to swim, right? You probably weren't that great at it. It was frustrating and you were probably a little scared, but you stuck with it, and I hope that you're able to swim now. There are a plethora of support resources when learning Linux. One good example is the discussion forum in the certificate course. Another avenue of support for learning Linux is just Googling answers, using Stack Overflow, maybe even making a Reddit post. I love working in cybersecurity. It's pretty satisfying to know that me and my team and then like all of the other security teams here at Google are helping protect people online from things they may not even know about.
There are so many others just like you who will be using the command line. Linux's popularity and ease of use has created a large online community that constantly publishes information to help users learn how to operate Linux. Since Linux is open source, it has become a global community of users that contribute frequently. This global community is a huge resource for all Linux users because users can find answers for everyday tasks. Just searching on the internet will provide many answers. The easiest way to troubleshoot a task is to search and read about how someone else has done it. Looking for resources on how to execute a task is a good way for beginners to continue learning. So far, you've learned how to add users, but imagine if later you wanted to add a new group. One way to learn how to do this is to search online. Let's give this a try through Google Search. The search results give us many options for adding a group in Linux. Another reputable source is a Unix and Linux Stack Exchange. Their answers are ranked with points to display high-quality answers. Many questions relate to more advanced users and are geared towards troubleshooting. Well, now you know where to get some extra support whenever in doubt about topics in Linux. There is a lot of support just a click away. Coming up, we'll learn how to get support from within the command line itself. Join me. Welcome back. In this video, we're going to discuss some resources that are available directly through the shell and can help you while working in Linux. One of the great things about Linux is that you can get help right through the command line. The first command that can help you in this way is man. Man displays information on other commands and how they work. The name of this command comes from the word manual. Let's examine this more closely by using man to get information about the user mod command. After man, we type the name of this command. The information that man returns includes a general description. It also contains information about each of user mod's options. For example, the option -d can be added to user mod to change a user's home directory. Man provides a lot of information, but sometimes we just need a quick reference on what a command does. In that case, you use what is. What is displays a description of a command on a single line. Let's say you heard a coworker mention a command like tail. You've never heard of this command before, but you can find out what it does. Simply use the command whatisTail and learn that it outputs the last part of files. Sometimes we might not even know what command to look up. This is where apropos can help us. Apropos searches the manual page descriptions for a specified string. Let's try it out. Let's say you have a task that requires you to change a password, but you're not quite sure how to do this. If we use the apropos command with the string password, this will display a large number of commands with that word. This helps somewhat, but it still may be difficult to find what we need. But we can filter this by adding the -a option and an additional string. This option will return only the commands that contain both strings. In our case, since we want to change the password, let's look for commands with both change and password. Now, the output has been limited to the most relevant commands. These commands make it a lot easier to navigate the Linux command line. As a new analyst, you won't have all the answers all the time, but you can learn where to find them. Congratulations! You completed another section in this course. Take a minute to think about what you achieved. You learned a lot in this section. Let's recap what we covered. In this section, you utilized the command line to communicate with the OS. Part of this was using commands for navigating and managing the file system. And you use other commands for authenticating and authorizing users. These are all tasks that a security analyst is likely to encounter. Finally, you learned about accessing resources that support learning new Linux commands. With this knowledge, you'll be able to continue learning more and more about using the command line. We did it. We learned how to communicate with Linux. That's a great accomplishment, and one that will be very useful to you in your career as a security analyst. You should be proud of the work that you've done so far. In the world of security, diversity is important. Diverse perspectives are often needed to find effective solutions. This is also true of the tools we use. Your job will often require you to use a lot of diverse tools. In the last section, we studied the Linux command line and learned how this tool can help you search and filter through data, navigate through the Linux file system, and authenticate users. Now, we'll learn about another tool. In this section, we'll explore SQL and how it allows you to analyze data in a way needed for your role as a security analyst. We're going to start off by learning about relational databases and how they're structured. From there, we're going to introduce SQL queries and how to use them to access data from databases. We then move on to SQL filters, which help us refine our queries to get the exact information we need. Lastly, we'll explore SQL joins, which allow you to combine tables together. When I'm presented with a problem or a project at work, I often have to sift through a large amount of data. When I use SQL, I'm able to review data quickly and provide results with confidence, since the queries are consistent and easily executed. SQL is a very powerful and flexible tool. Throughout this section, you'll learn how to use the parts of it you need as a security analyst and gain hands-on experience. Good luck, and I'll join you for the rest of the course. Our modern world is filled with data, and that data almost always guides us in making important decisions. When working with large amounts of data, we need to know how to store it so it's organized and quick to access and process. The solution to this is through databases, and that's what we're exploring in this video. To start us off, we can define a database as an organized collection of information or data. Databases are often compared to spreadsheets. Some of you may have used Google Sheets or another common spreadsheet program in the past. While these programs are convenient ways to store data, spreadsheets are often designed for a single user or a small team to store less data. In contrast, databases can be accessed by multiple people simultaneously and can store massive amounts of data. Databases can also perform complex tasks while accessing data. As a security analyst, you'll often need to access databases containing useful information. For example, These could be databases containing information on login attempts, software and updates, or machines and their owners. Now that we know how important databases are for us, let's talk about how they're organized and how we can interact with them. Using databases allow us to store large amounts of data while keeping it quick and easy to access. There are lots of different ways we could structure a database, but in this course, we'll be working with relational databases. A relational database is a structured database containing tables that are related to each other. Let's learn more about what makes a relational database. We'll start by examining an individual table in a larger database of organizational information. Each table contains fields of information. For example, in this table on employees, these would include fields like employee ID, device ID, and username. These are the columns of the tables. In addition, tables contain rows, also called records. Rows are filled with specific data related to the columns in the table. For example, our first row is a record for an employee whose ID is 1000 and who works in the marketing department. Relational databases often have multiple tables. Consider an example where we have two tables from a larger database, one with employees of the company and another with machines given to those employees. We can connect two tables if they share a common column. In this example, we establish a relationship between them with a common employee ID column. The columns that relate two tables to each other are called keys. There are two types of keys. The first is called a primary key. The primary key refers to a column where every row has a unique entry. The primary key must not have any duplicate values or any null or empty values. The primary key allows us to uniquely identify every row in our table. For the table of employees, employee ID is a primary key. Every employee ID is unique and there are no employee IDs that are duplicate or empty. The second type of key is a foreign key. The foreign key is a column in a table that is a primary key in another table. Foreign keys, unlike primary keys, can have empty values and duplicates. The foreign key allows us to connect two tables together. In our example, we can look at the employee ID column in the machines table. We previously identified this as the primary key in the employees table, so we can use this to connect every machine to their corresponding employee. It's also important to note that a table can only have one primary key, but multiple foreign keys. With this information, we're ready to move on to the basics of SQL, the language that lets us work with databases. Throughout this section, we'll gain hands-on experience working with the concepts we just covered. As a security analyst, you'll need to be familiar both with databases and the tools used to access them. Now that we know the basics of databases, let's focus on an important tool used to work with them, SQL, and learn more about how analysts like yourself might utilize it. SQL, or as it's also pronounced, SQL, stands for Structured Query Language. SQL is a programming language used to create, interact with, and request information from a database. Before learning more about SQL, we need to define what query means. A query is a request for data from a database table or a combination of tables. Nearly all relational databases rely on some version of SQL to query data. The different versions of SQL only have slight differences in their structure, like where to place quotation marks. Whatever variety of SQL you use, you'll find it to be a very important tool in your work as a security analyst. First, let's discuss how SQL can help you retrieve logs. A log is a record of events that occur within an organization's systems. As a security analyst, you might be tasked with reviewing logs for various reasons. For example, some logs might contain details on machines used in a company, and as an analyst, you would need to find those machines that weren't configured properly. Other logs might describe the visitors to your website or web app and the tasks they perform. In that case, you might be looking for unusual patterns that may point to malicious activity. Security logs are often very large and hard to process. There are millions of data points, and it's very time-consuming to find what you need. But this is where SQL comes in. It can search through millions of data points to extract relevant rows of data using one query that takes seconds to run. That's pretty useful, right? SQL is also a very common language used for basic data analytics, another set of skills that will set you apart as a security analyst. As a security analyst, You can use SQL's filtering to find data to support security-related decisions and analyze when things may go wrong. For instance, you can identify what machines haven't received the latest patch. This is important because patches are updates that help secure against attacks. As another example, you can use SQL to determine the best time to update a machine based on when it's least used. Now that we know why SQL is important to us, we're going to start making basic queries to a sample database. This is definitely exciting, and I'll meet you in the next video.
Hi, my name is Adedayo, and I'm a security engineer at Google. A lot of people think you need to have a degree in computer science, right, to be able to get into cybersecurity. I don't think that's true. Take me for an example. I started learning IT from Lagos, Nigeria, where I was born and raised, and then I'm all the way here now in Silicon Valley working for Google, and I think that's just amazing and a dream come true. You taking this certificate is a first step to you making a commitment to switching your career to cybersecurity, so kudos to you on that. SQL is one of the skill set you need to have in your toolbox as a cybersecurity professional because you can very quickly make decisions, not just off the bat, but make decisions with data backing you and be able to communicate with your team, with stakeholders about why you made a decision. Because it's one thing to be able to say, we need to do this, right? It's another thing to say, we need to do this, and here's the data that I wrote my SQL statements about. I learned SQL by first as a coursework in school. That was really great, but I think I kind of forgot everything about that after school. The next step that I took was taking online courses, such as the one you're taking right now, to learn SQL and the fundamentals about it and how to really use it. And then the first time I used SQL practically was at Google. You really need to practice. I think with anything else, practice makes perfect, right? So being able to, even if it's just a few hours a week, put aside time to practice writing SQL statements. Having that skill is something that will be very applicable to your first job, and you can use that to make data-driven decisions. I feel very fulfilled working in cybersecurity. I feel very energized coming to work every day, not only because I get to work on really complex problems and try to figure solutions for them, but I also have great teammates that we all come together and tackle the problem. Being able to go to bed at night, knowing that the work that I do is for the better of Google users and Google employees is a very rewarding feeling for me.
In this video, we're going to be running our very first SQL query. This query will be based on a common work task that you might encounter as a security analyst. We're going to determine which computer has been assigned to a certain employee. Let's say we have access to the employees table, and the employees table has 5 columns. 2 of them, employee ID and device ID, contain the information that we need. We'll write a query to this table that returns only those 2 columns from the table. The 2 SQL keywords we need for basic SQL queries are select and from. Select indicates which columns to return. From indicates which table to query. The use of these keywords in SQL is very similar to how we would use these words in everyday language. For example, we could ask a friend to select apples and bananas from the big box when going out to buy fruit. This is already very similar to SQL. So let's go ahead and use select and from in SQL to return the information we need on employees and the computers they use. We start off by typing in the SQL statement. After from, we've identified that the information will be pulled from the employees table. And after select, employee ID and device ID indicate the 2 columns we want to return from this table. Notice how a comma separates the 2 columns that we want to return. It's also worth mentioning a couple of key aspects related to the syntax of SQL here. Syntax refers to the rules that determine what is correctly structured in a computing language. In SQL, keywords are not case sensitive, so you could also write select and from in lowercase. but we're placing them in capital letters because it makes the query easier to understand. Another aspect of the syntax is that semicolons are placed at the end of the statement. And now, we'll run the query by pressing enter. The output gives us the information we need to match employees to their computers. We just ran our very first SQL query. Suppose we wanted to know what department the employee using the computer is from, or their username, or the office they work in. To do that, we can use SQL to make another statement that prints out all of the columns from the table. We can do this by placing an asterisk after select. This is commonly referred to as select all. Now, let's run this query to the employees table in SQL. And now we have the full table in the output. You just made it through a basic query in SQL. Congratulations! In the next video, we'll learn how to add filters to our queries. So I'll meet you there. One of the most powerful features of SQL is its ability to filter. In this video, we're going to learn how this helps us make better queries and select more specific pieces of data from a database. Filtering is selecting data that match a certain condition. Think of filtering as a way of only choosing the data we want. Let's say we wanted to select apples from a fruit cart. Filtering allows us to specify what kind of apples we want to choose. When we go by apples, we might explicitly say, choose only apples that are fresh. This removes apples that aren't fresh from the selection. This is a filter. As a security analyst, you might filter a login attempts table to find all attempts from a specific country. This could be done by applying a filter on the country column. For example, you could filter to just return records containing Canada. Before we get started, we need to focus on an important part of the syntax of SQL. Let's learn about operators. An operator is a symbol or keyword that represents an operation. An example of an operator would be the equal to operator. For example, if we wanted to find all records that have USA in the country column, we use country equals USA. To filter a query in SQL, we simply add an extra line to the select and from statement we used before. This extra line will use a where clause. In SQL, where indicates a condition for a filter. After the keyword where, the specific condition is listed using operators. So if we wanted to find all of the login attempts made in the United States, we would create this filter. In this particular condition, we're indicating to return all records that have a value in the country column that is equal to USA. Let's try putting it all together in SQL. We're going to start with selecting all the columns from the log_in_attempts table, and then add the where filter. Don't forget the semicolon. This tells us we finished the SQL statement. Now, let's run this query. Because of our filter, only the rows where the country of the login attempts was USA are returned. In the previous example, the condition for our filter was based simply on returning records that are equal to a particular value. We can also make our conditions more complex by searching for a pattern instead of an exact word. For example, in the employees table, we have a column for office. We could search for records in this column that match a certain pattern. Perhaps we might want all offices in the East building. To search for a pattern, we use the percentage sign to act as a wildcard for unspecified characters. If we ran a filter for East percentage sign, this would return all records that start with East. For example, the offices East 120, East 290, and East 435. When searching for patterns with the percentage sign, we cannot use the equals operator. Instead, we use another operator, like. Like is an operator used with where to search for a pattern in a column. Since like is an operator, similar to the equal sign, we use it instead of the equal sign. So, when our goal is to return all values in the office column that start with the word East, like would appear in a where clause. Let's go back to the example in which we wanted to filter for login attempts made in the United States. Imagine that we realize our database contains inconsistencies with how the United States is represented. Some entries use US, while others use USA. Let's get into SQL and apply this new type of filter with like. We're going to start with the same first 2 lines of code because we want to select all columns from the login attempts table. And we're going to add a filter with like, so that records will be returned if they contain a value in the country column beginning with the characters US. This includes both US and USA. Let's run this query to check if the output changes. This returns all the entries where the user location was in the United States. And now we can use the like clause to filter columns based on a pattern. Wow, we've already learned how to get very precise with our database and get exactly the data we need with one single query. I'm excited for what's next. In this video, we're going to continue using SQL queries and filters, but now we're going to apply them to new data types. First, let's explore the 3 common data types that you will find in databases: string, numeric, and date and time. String data is data consisting of an ordered sequence of characters. These characters could be numbers, letters, or symbols. For example, you'll encounter string data in usernames, such as a username analyst10. Numeric data is data consisting of numbers, such as a count of login attempts. Unlike strings, mathematical operations can be used on numeric data, like multiplication or addition. Date and time data refers to data representing a date and/or time. Previously, we applied filters using string data, but now let's work with numeric and date and time data. As a security analyst, you'll often need to query numbers and dates. For example, we could filter patch dates to find machines that need an update. Or we could filter login attempts to return only those made in a certain period of time. We learned about operators in the last video, and we're going to use them again for numbers and dates. Common operators for working with numeric or date and time data types include equals, greater than, less than, not equal to, greater than or equal to, and less than or equal to. Let's say you want to find the login attempts made after 6 p.m. Because this is past normal business hours, you want to look for suspicious patterns. You can identify these attempts by using the greater than operator in your filter. We'll start writing our query in SQL. We begin by indicating that we want to select all columns from the log_in_temps table. Then, we'll add our filter with where. Our condition indicates that the value in the time column must be greater than, or for dates and times, later than 1800, which is how 6 p.m. is written in SQL. Let's run this and examine the output. Perfect! Now we have a list of login attempts made after 6 p.m. We can also filter for numbers and dates by using the between operator. Between is an operator that filters for numbers or dates within a range. An example of this would be when looking for all patches installed within a certain range. Let's do this. Let's find all the patches installed between March 1st, 2021 and September 1st, 2021. In our query, we start with selecting all records from the machines table. And we add the between operator in the where statement. Let's break down the statement. First, after where, we indicate which column to filter. In our case, OS_patch_date. Next comes our operator between. We then add the beginning of our range, type and, then finish by adding the end of our range, and a semicolon. Now, let's run this and explore the output. And now we have a list of all machines patched between those 2 dates. Before we wrap up, an important thing to note is that when we filter for strings, dates, and times, we use quotation marks to specify what we're looking for. However, for numbers, we don't use quotation marks. With this new knowledge, you're now ready to work on all sorts of interesting filters for numbers and dates. In the next video, we'll be able to expand our filtering even further by using multiple conditions in one query. In the previous lesson, we learned about even more ways to filter queries in SQL to work with some typical security analyst tasks. However, when working with real security questions, we often have to filter for multiple conditions. Vulnerabilities, for instance, might depend on more than one factor. For example, a security vulnerability might be related to machines using a specific email client on a specific operating system. So to find the possible vulnerabilities, we need to find machines using both the email client and the operating system. To make a query with multiple conditions that must be met, we use the AND operator between two separate conditions. AND is an operator that specifies that both conditions must be met simultaneously. Bringing this back to our fruit and vegetable analogy, this is the same as asking someone to select apples from the big box where the apples are large and fresh. This means our results won't include any small apples even if they're fresh, or any rotten apples even if they're large. They'll only include large, fresh apples. The apples must meet both conditions. Going back to our database, the machines table lists all operating systems and email clients. We want a list of machines running operating system 1 and a list of machines using email client 1. We'll use the left and right circles in the Venn diagram to represent these groups. We need SQL to select the machines that have both OS1 and email client 1. The filled-in area at the intersection of these circles represents this condition. Let's take this and implement it in SQL. First, we're going to start by building the first lines of the query, telling SQL to select all columns from the machines table. Then, we'll add the where clause. Let's examine this more closely. First, we indicate the first condition that it must meet, that the operating system column has a value of OS1. Then, we use AND to join this to another condition. And finally, we enter the other condition. In this case, that the email client column should have a value of email client 1. And this is how you use the AND operator in SQL. Let's run this to get the query results. Perfect! All the results match both our conditions. Let's keep going and explore more ways to combine different conditions by working with the OR operator. The OR operator is an operator that specifies that either condition can be met. In a Venn diagram, let's say each circle represents a condition. When they are joined with OR, SQL would select all rows that satisfy one of the conditions. And it's also okay if it meets both conditions. Let's run another query and use the OR operator. Let's say that we wanted the filter to identify machines that have either OS1 or OS3 because both types need a patch. We'll type in these conditions. Let's examine this more closely. After where, our first condition indicates we want to filter so that the query selects machines with OS1. We use the OR operator because we also want to find records that match another condition. This additional condition is placed after OR and indicates to also select machines running OS3. Executing the query, our results now include records that have a value of either OS1 or OS3 in the operating system column. Good job! We're running some complex queries. The last operator we're going to go into is the NOT operator. NOT negates the condition. In a diagram, we can show this by selecting every entry that does not match our condition. The condition is represented by the circle. The filled-in portion outside the circle represents what gets returned. This is all data that does not match the condition. For example, when picking out fruit, you could be looking for any fruit that is not an apple. That is a lot more efficient than telling your friend you want a banana or an orange or a lime, and so on. Suppose you wanted to update all the devices in your company except for the ones using OS 3. Bringing this into SQL, we can write this query. We place not after where and before the condition of the filter. Executing these queries gives us the list of all the machines that aren't running OS 3, and now we know which machines to update. That was a lot of new content that we just looked into, but you're learning more and more SQL that you can use on your journey to become an analyst. In the next video, we'll be learning how to combine and join two tables together to expand the kinds of queries we can run. I'll meet you there. You've already learned a lot about SQL queries and filters. Nice work! The last concept we're introducing in this section is joining tables when querying a database. This is helpful when you need information from two different tables in a database. Let's say we have two tables, one that tells us about security vulnerabilities of different operating systems, and one about different machines in our company, including their operating systems. Having the ability to combine them gives us a list of vulnerable machines. That's pretty cool, right? First, let's start talking about the syntax of joins. Since we're working with two tables now, we need a way to tell SQL what table we're picking columns from. In our example database, we have an employee ID column in both the employees table and the machines table. In SQL statements that contain two columns, SQL needs to know which column we're referring to. The way to resolve this is by writing the name of the table first, then a period, and then the name of the column. So, we would have employees followed by a period, followed by the column name. This is the employee ID column for the employees table. Similarly, this is the employee ID column for the machines table. Now that we understand the syntax, let's apply it to a join. Imagine that we want to get a deeper understanding of the employees accessing the machines in our company. By joining the employees and the machines tables, we can do this. We first need to identify the shared column that we'll use to connect the two tables. In this case, we'll use a primary key in one table to connect to another table where it's a foreign key. The primary key of the employees table is employee ID, which is a foreign key in the machines table. Employee ID is a primary key in the employees table because it has a unique value for every row in the employees table, and no empty values. We don't have a guarantee that the employee ID column in the machines table follows the same criteria since it's a foreign key and not a primary key. Next, we'll use a type of join called an inner join. An inner join returns rows matching on a specified column that exists in more than one table. Tables usually contain many more rows, but to further explain what we mean by inner join, let's focus on just 4 rows from the employees table and 4 rows from the machines table. We'll also look at just a few columns of each table for this example. Let's say we choose employee ID in both tables to perform an inner join. Let's look at the 2 rows where there is a match. Both tables have 1188 and 1189 in their respective employee ID columns, so they are considered a match. The result of the join is the 2 rows that have 1188 and 1189, and all columns from both tables. Before we move on to the queries, we have to talk about the null values in the tables. In SQL, null represents a missing value due to any reason. In this case, this might be machines that are not assigned to any employee. Now, let's bring this into SQL and do an inner join on the full tables. Let's imagine we want to join these tables in order to get a list of users and their office location that also shows what operating system they use on their machines. Employee ID is a common column between these tables, and we can use this to join them. But we won't need to show this column in the results. First, let's start with a basic query that indicates we want to select the username, office, and operating system columns. We want employees to be our first or left table, so we'll use that in our from statement. Now we write the part of the query that tells SQL to join the machines table with the employees table. Let's break down this query. Inner join tells SQL to perform the inner join. Then, we name the second table we want to combine with the first. This is called the right table. In this case, we want to join machines with the employees table that was already identified after from. Lastly, we tell SQL what column to base the join on. In our case, we're using the employee ID column. Since we're using two tables, we have to identify the table and follow that with the column name. So we have employees.employeeID and machines.employeeID. Let's review the output. Perfect. We have now joined two tables. The result of our query displays the records that match on the employee ID column. Notice that these records contain columns from both tables, but only the ones we indicated through our select statement. There are other types of joins that don't require a match to join two tables, and we're going to discuss those in the next video. I'll meet you there. Welcome back. I hope you enjoyed working on inner joins. In the previous video and exercises, we saw how inner joins can be useful by only returning records that share a value in specified columns. However, in some situations, we might need all of the entries from one or both of our tables. This is where we need to use outer joins. There are three types of outer joins: left join, right join, and full outer join. Similar to inner joins, outer joins combine two tables together. However, they don't necessarily need to match between columns to return a row. Which rows are returned depends on the type of join. Left join returns all of the records of the first table, but only returns rows of the second table that match on a specified column. Like we did in the previous video, let's examine this type of join by looking at just 4 rows of 2 tables with a small number of columns. Employees is the left table, or the first table, and the machines is the right table, or the second table. Let's join on employee ID. There's a matching value in this column for 2 of 4 records. When we execute the join, SQL returns these rows with the matching value, all other rows from the left table, and all columns from both tables. Records from the employees table that didn't match but were returned through the left join contain null values in columns that came from the machines table. Next, let's talk about right joins. Right join returns all of the records of the second table, but only returns rows from the first table that match on a specified column. With a right join on the previous example, the full result returns matching rows from both, all the rows from the second table, and all the columns in both tables. For the values that don't exist in either table, we are left with a null value. Last, we'll discuss full outer joins. Full outer join returns all records from both tables. Using our same example, a full outer join returns all columns from all tables. If a row doesn't have a value for a particular column, it returns null. For example, the machines table did not have any rows with employee ID 1190, so the values for that row in the columns that came from the machines table is null. To implement left joins, right joins, and full outer joins in SQL, you use the same syntax structure as the inner join, but use these keywords: left join, right join, and full outer join. As a security analyst, you're not required to know all of these from memory. Once you understand the type of join you need, you can quickly search and find all the information you need to execute these queries. With this information on joins, we've now covered some very important information you'll need as a security analyst using SQL. Thank you for joining me in this video. Congratulations! We've made it together through the end of our focus on SQL. You've put in a lot of work and learned an important tool that will help you on your journey as a security analyst. Let's take a moment to go through all of the topics you learned in this section. We started by learning about the structure of relational databases and how we can access them by using the query language SQL. We then got hands-on practice with writing our own SQL queries. We use SQL to bring up information you might need on the job when working as an analyst. We then focused on SQL filters. We started with simple conditions with strings, and by the end, we learned how to use multiple filters in one query. We concluded the unit with SQL joins and learned how to join multiple tables, giving us even more information at once. By completing this course, you just took a very big step in your future career as a security analyst. You have been introduced to a powerful tool that can help you in your work. And whenever you need to, I encourage you to revisit the materials in this course. Learning a querying language like SQL takes time. Thank you again for joining me in this journey. I hope you'll enjoy using SQL as much as I do. You made it to the end of this course. Congratulations! You did it! I hope you are proud of all you learned. The focus of this course was computing basics. Understanding the basics of computing is a valuable skill as you transition into your career as a security analyst. Let's recap what you learned in this course. We first focused on operating systems and how they relate to applications and hardware. Understanding how the system you're protecting works is essential for doing your job effectively. That brings us to the Linux operating system. When working in the security profession, familiarity with Linux is important. We first discuss its architecture and various distributions. Then, we use a Linux command line to carry out tasks you might encounter as a security analyst. Finally, we looked at another useful tool and used SQL to query databases. After this course, I hope you have a better understanding of how these foundations of computing support a security analyst in their daily work. I also hope you continue your path with this program. There are a lot of other useful and exciting topics ahead. Once again, congratulations. You finished another course. Building skills is something you should be proud of. Keep it up as you progress through this program.